Hello, everybody. I'm afraid we've had a terrible problem actually getting our act together here. We started on Skype, we've moved to Zoom, and so we're almost 40 minutes late in starting. Sorry about that. And we've only got a 40-minute window on Zoom, so we're going to have to be fairly quick. Anyway, welcome to the British Interplanetary Society's 6th live streaming Q&A. I hope we don't have as many problems as we've had just now, but I'm relying on Alan to sort it all out. For those who don't know me, I'm Alistair Scott, a past president of the Society, but now just trying to coordinate the events program. If at any time YouTube link fails, I understand you should just click on the same URL or the link and rejoin the session at a more or less the same point. I hope you've all had a chance to watch Michael's interesting talk on elementary astrobiology. I have to admit, it's really not my subject at all, but I did learn a lot. As you will no doubt know, Michael is a lawyer with a tremendous interest in things about space. He has been a member of the BIS for a long, long time. In fact, with a membership number in the 700s, I was probably in short trousers or a kilt at the time. Anyway, I'm pleased to have him with us tonight to answer your questions. We really already have a number of questions, but if you have any more, please email them to me as soon as possible on streaming@bis-space.com. Now, I'll hand over quickly to Michael to say a couple of words while I find the questions. Over to you, Michael.
Right. Okay. Hello. It's nice to see you all. We've had a tremendous trouble to get here. We're now on Zoom rather than any other means, and we seem to be able to talk. Now, I'm waiting to be fed the questions, which are which have been sent by email. So I'm ready.
We've got a load of them.
Oh, good.
Whoops, I've lost them again. This is the trouble with going through so many.
Yeah, screen after screen after screen.
Right, here we are. Question 1. Question 1 is from Les Shoulder, a fellow of the British Interplanetary Society, on the London-Essex border and looking for somewhere cooler, aren't we all?
Yeah.
When talking about the Fermi paradox and the apparent lack of other intelligent life in the galaxy, you mentioned the hypothesis put forward by Elon Musk, amongst others, that we are part of a computer simulation. You used the word elegant. I don't think that's the word I would have used. Can you explain more on why this attracts you?
Well, it doesn't attract me, but it's an elegant solution because it's a very simple solution to the problem, i.e., we can't find the other aliens because we're in a simulation and they won't let us see them. That's a very, very simple idea, and that's why I said it was elegant. There's loads of other ideas about the Fermi paradox, but that was one that attracted Musk, and he's quite clever, so there we go. And he has gone on about several times thinking we're just in a simulation, and the difficult question is, how can we test whether we are actually alive or just in a simulation? And that's very tricky.
Right, well, thank you. Question 2 is again from Les Shoulder, still on the Essex border, and still looking for somewhere cooler. And he says, with life on Earth in various simple or more complex forms existing from the depths of the ocean trenches to high in the atmosphere, do you think that life, leaving aside intelligence, is almost inevitable on extraterrestrial planets if the right starting blocks are available?
The real problem we have is we only have a sample size of 1. And when you try and extrapolate from a sample size of 1, you can get anything. However, the interesting thing is that life started on Earth fairly quickly. As soon as the Earth was habitable, there seems to be life forms on it. Now, that's only an indication, but it would suggest that if life could form on Earth very quickly, it ought to have formed elsewhere, because one of the basic rules we work on is that there's nothing special about Earth or our solar system. So if life happens, it's going to happen elsewhere.
Right. Okay. Well, let's hope so. Now, I've got a tricky question for you here from Paul McDermott. He's an expert, so we might not be able to answer or add anything to the answer. He says, if not discussed in the presentation, what is the impact of the salt environment based on chaotropic and cosmotropic effects on macromolecular stability on the likelihood of the emergence of life, and how shall that inform us of the potentially simpler way of prioritizing attention? Actually, he's given me an update to that. So I don't know whether you want to answer it to that. What I've done is
I'll listen to the update, but I think I can do an answer. Do you want to give me the updated question?
Yeah, I'm just looking for it. It's come in a separate email, and I'm just trying to find it. No, lost it again. It's the problem. Too many emails open.
Yeah. Shall I start on answering his question?
Right. Well, I've got it. I've got it now.
Okay.
Right. He says on the likelihood of the emergence of life, and how shall that inform us for a potentially simple way of prioritizing attention, e.g., sodium chloride is supportive of macromolecular structure, magnesium dichloride is not, as shown in biodeep projects in subsea magnesium dichlorate basins in the Mediterranean. Over to you.
Right. Well, the basic thing is life appears to be a self-sustaining chemical system capable of Darwinian evolution. So in order for the chemistry to work, it needs to be in liquid form. And if you have halides in liquid, they can dry out the liquid and they can create pressures to suck the moisture out. So in a very, very salty solution like the Dead Sea, life just about exists, but it has to be highly specialized. So I'm not sure that the type of life that likes salt solution is called halophilic, i.e. like salts, and it's an adaptation. Most life don't like very salty solutions. I don't think looking for salty solutions will really tell us anything. The classic marker for life is if you have an atmosphere which has a lot of oxygen, because the only way you can get oxygen is with photosynthesis, which is definitely something life does. So I'm not sure looking for salty solutions will really help you sort out the planets that has life once we can analyze planetary atmospheres, which we can't do anyway at the moment. I hope that answers the question.
Well, I'm sure it goes part the way there. So I'll let Paul come back. He might come back a bit later in the talk here, and we'll see if he's got any more questions. He can probably shed more light on it than we can.
Yeah, I mean, the extremophiles which can tolerate halide salts are very, very interesting, but they're possibly a side step in evolution, and they're probably not where life originated.
Right.
But it's all guesswork anyway.
Okay, well, thank you for that one. Yeah. And let's move on to the next one. Actually, the next question is from me in a rather dull and thundery Bedford. Yeah, from what you've said, the Drake equation is supposed to be able to tell us the likelihood of there being other life in our galaxy, the possible number of other civilizations. But as you say, the big unknown is L, the length of time a civilization has been communicating externally, not just internally. Now, SETI found or heard nothing for its 20 years search. And could it be, like our 80 years of external communications by radio and radar, their 80 years possibly taking millions of light years to reach us hasn't got here yet. It's the eggshell idea, I believe.
Yeah, that is true, because the thing is that there's a sort of bubble of radio signals coming from Earth that are gradually permeating the universe, and that bubble is getting bigger every year. And so in theory, at some stage, someone will spot something. Though obviously by the time it's got out into deep space, it's going to be very, very, very faint. On the other hand, their technology may be able to pick up extremely faint, coherent signals, because that will be what they're looking for. Signals that seem to make some sort of sense, even though they can't decode them just yet. So it's a possible solution. The thing is, the universe is absolutely vast, and we're only talking about our own galaxy, and there's hundreds and thousands of galaxies. So if there was another a very sophisticated civilization, say, 2 or 3 bit. Oh, what was that? Did you get it?
I think I've got another question coming back from Paul.
Right. Oh, good. So I was saying, even if there is life somewhere else in the universe, we may never be able to communicate with it because of the difficulties of communicating with light waves.
Yeah.
Electromagnetic radiation. Right.
Okay, well, thank you for that. I'm still a little bit unsure of what it all will mean. But anyway,
Yeah.
I'll come back to Paul in a moment. But I've got another one here, which is from Alan Marlowe himself. And
good.
He says, I believe a sample of fungus or algae was left on the outside of the ISS for an extended period of some months and survived. Does that indicate that transfer of living organisms on comets, etc., is possible and may have been how life arrived on Earth?
Right. This is what some astrobiologists really hate, because they feel if you have this idea, which is technically called spermia, you're sort of delaying things, because you're saying life evolved somewhere else, so there was no need for it to evolve on Earth because Earth was seeded. So it really postpones the question of how did life start, because it's a slight cop-out if you say, well, life didn't actually originate on Earth, we just got hit by a bit of Mars that happened to be alive. So some astrobiologists really hate it and think it's unnecessary, and if life evolved, it probably just evolved on Earth and didn't need to evolve anywhere else. So that's the problem. But on the other hand, it is quite conceivable that there's certainly stuff flying out from Earth heading for Mars. And one of the astrobiological nightmares is when we get to Mars, we find it's full of Earth life below the soil in the nice damp sand, being heated by the weak sun.
Right. Okay. Well, I've got some more questions coming in here, so I'm just trying to find them. Right. It's Paul. Yes. Okay. It's Paul saying, okay, it's probably too much. So he says thanks, but you misinterpreted the question, and I've got another one in here from him, which I'm just. Well, yeah, okay, a good attempt. So he says, well done.
Okay.
So I'm going to now move on to actually some of the questions you raised, because we're going to run out of time fairly soon. And the questions that you asked at the end of your talk, perhaps you'd like to answer some of those. So if I read them out one by one, I'm just trying to find them. I know they're here somewhere.
Yeah.
Let me just get out of that one, and I'll get out of that one too. Right. So, first question you asked was, how old is the universe?
Well, the current theory is it's around 13 billion years old.
Right.
13.5, I think, but which is an incredibly long period.
Yep. So the eggshell is pretty thin.
Yeah.
Yeah. Right. The second question was, how old is the solar system?
Well, that's quite young. It's only 3.5 billion years old, so it's only about a third of the age of the universe, which is actually interesting. And I'll come on to that in the next questions.
Ah, right. How many elements are necessary for life?
Now, this is an extremely interesting question. The best answer seems to be there are 25 elements necessary for life. Now, not all of those elements would have been formed in the Big Bang. The Big Bang produced hydrogen and helium, plus a few other elements. So at the time of the Big Bang, any stars which form planetary systems, it would have been impossible for our type of life to exist because the elements weren't there. This may be a possible part solution to Fermi. So you have to wait till you've got second or third generation stars and their planets to have the elements necessary for life.
Right. Okay. So we now know. Right. Number 4 is, what were the names of the probes that were sent to Mars in 1975 to look for life?
Well, this is quite fun. They were Vikings for some weird reason.
Yep.
And the Vikings were nasty marauders, so why they chose to call them Vikings beats me.
Well, maybe our American colleagues didn't quite realize who the Vikings were and what great warriors they were. Maybe they were right. You needed a warrior to go to Mars.
Yeah.
After all, Mars is the god of war as well.
Maybe that was why.
Maybe. Yep. Right. So number 5 is, what is the purpose of the Drake equation? Well, I think we've already answered some of that.
It's an attempt to work out whether how many civilizations there may be that can communicate. It's fairly basic, but it's just I think it's a good thought experiment. Yeah.
Yeah. Right. Okay. Number 6, who was burnt at the stake for suggesting there is life on other worlds?
This is Bruno, who fell foul of the Inquisition, it's quite extraordinary that someone at that time, and it was only shortly after Galileo discovered the moon, started talking about life on other worlds. How could have thought that? So it's very strange. Anyway, he was the first astrobiologist. Right.
Okay. He paid the price for it then.
Yeah.
Let's hope it doesn't happen again. Yeah, funnily enough, we named one of our first ExoMars rovers, Bruno. But that was because it began with BR. I don't think it was any relation. No. Right, let's go on to the number 7. When was the first radio telescope built?
Remember, it's quite late. I think it's 1928. It's a very strange thing. It looks like a Wright flyer. There's a contraction of wires and so on.
Right. Okay. So, and was it in the USA?
It was in the USA, and it was a part experiment. But as I say, it wasn't that long ago.
No. Right, we've got number 8 here, and it's very up to date on the question here. Are viruses alive?
No. This is where you go back. The definition that's used to define life is a self-sustaining chemical system capable of undergoing Darwinian evolution. Now, the point about viruses, they're not self-sustaining. We've had a gift from Zoom. We can carry on. Right, so viruses need other cells in order to produce their RNA and DNA, and they cannot live without another life form. So without other life forms. So strictly speaking, if you follow that definition, they're not alive.
Right.
Which is,
okay. So they're not alive. Yes, they have to live on other bodies, don't they?
yeah. So that they're very parasitic.
Yeah. Right. Well, number 9 is, what are the first fossils called?
Sorry, what's that?
What
First
are the
fossil.
first fossils
First,
called?
right. The first fossils that we've got are stromatolites, which were cyanobacteria which carried out photosynthesis, and they're sort of like lumps of rock. And there's the famous place where they're still to be found is Shark Bay in Australia. There was a screenshot of stromatolites. I've got a stromatolite fossil, but not to hand. So they are interesting things, and they're still alive today.
Right. Okay. The next one, and the final one from your list, is number 10. What do all forms of life need?
Right. Well, this sort of loops back to some of the earlier questions. Life is a chemical system, so it needs a source of energy, and it needs a liquid in which to carry out the chemical reactions, because without the liquid, it's difficult to do the type of chemical reactions necessary for life. And so it needs liquid, and it needs a source of energy, because without energy, nothing can live. So,
right. Okay. I've got an email just arrived in from Jerry Stone. It's more of a statement than a question. He says, I've given my presentation, Life in the Universe, many times, and something that I mention is how the Drake equation takes a subset of the previous total as it moves through the various terms. However, it simply repeatedly asks, what proportion of these then satisfy the next condition, without asking about the circumstances that might have led to the existence of life on a given planet. One major factor on Earth was not simply water, but a very large moon, which produced tides in the water. This led to life forms attempting to exist on land, rather, which was necessary in the line to producing an intelligent civilization. Right, we have the answer to all there.
Yeah. So it's interesting. One of the unique features of Earth is its large moon, because I don't think there's any other planet in the solar system that has a large moon. But simply because the Earth is the only planet we know in the solar system that has life does not necessarily mean that the moon is essential for life. It's quite easy to see how life could have evolved without the moon. The crucial thing is water and energy. And I suppose having tides, which have had a major effect on life, including human biology, is interesting, but I'm not convinced it would be essential.
Right. Well, I think we've probably exceeded our time limit now. I hope we're able to just finish off quickly. And if I may, I think that's the last of the questions I've got here. If anyone has any questions, they can come back to me and I'll send them on to you so you can communicate directly with them. But it's great to have had you on board. I'm sorry for all the problems in getting the system up and running. Next time we might start with Zoom and see if it works for longer.
Yes, sorry about that.
That certainly was a problem our end as well. But thank you very much for coming on board. Thank you very much for your interesting presentation. And let's carry on from there. I know Jerry's now running his space program, so he'll be keen to know when we can get out there, when we can set up colonies out there. So you might like to help him with that.
Yes.
But my next talk, actually, after I've thanked you and Alan for making this happen, the next talk is on I think the 2nd of September, where we're going to have John Davis from the Edinburgh Observatory talking about ever-decreasing circles, which is really a breakdown or an introduction to the orbits required for various missions around the Earth. So it'll be a very interesting one, and I'm hoping, in fact, I think it's already been recorded, so we should be able to have the Q&A on the 2nd of April. I've got an interesting one lined up for October, but I still can't tell you what it's about because I don't know. So let's hope we can go right through. We're planning to go right through to Christmas with these talks and hoping that we actually can get back into the BIS in the new year with some panel discussions and also a bit more in the way of conferences. So thank you all very much for joining us tonight. I'm sorry for the chaos in getting set up. We'll try and get it right next time. And thank you, Alan. And thank you also, Michael, for coming on board. Thanks a lot.
Thank you. It was a nice,
okay, bye-bye.
good experience. Bye-bye.
Bye.